transducer. So the basic concept of sensor and transducer I have discussed. So today I will start with that. That means continue our previous studies like your sensor transducer. Then the next one is your strain gauge. Okay. So in this case, that I told you the different types of strain gauges are there. Okay, strain gauges are there. Normally, the transducer is based on the stress and strain. Okay, so you have to know what are the different types of strain gauges are there. Okay, so before starting that module, so we need to know some important points. Okay, what is stress? Okay, so stress is a measure of the average point amount of force. Okay, stress is an example of a force per unit area applied per unit area. It is a measure of a intensity of the total internal forces, okay, acting within body across imaginary internal surface as a reaction to external applied force and the body forces. So from that formula you can understand the stress sigma equal to F by A. Okay, force applied per unit area. That is our stress. Okay, where sigma is your average stress and for called the nominal stress, and F is the force acting over the area A. Okay. So next one is your strain. Okay, strain is an geometrical expressions for the deformation caused by the action of stress. Okay, on a physical body. Strain is calculated by first assuming a change between two body states. Okay, beginning the states and the final states. So two body states are there. Then the difference in placement of 2 points in this body in those two state express the numerical values of the strain. So you can see what is that expression of strain. Okay, so here you get that expression of stress. Okay, the strain equals to the deformations of linear deformations, change of linear deformations with your length. Okay, the original length. So you can say like that it is a unitless, but here you can say that Newton per meter square, like that way. Okay, the unit of the stress is force per unit area, na? So it is Newton per meter square, like that. But in case of strain it is unitless. So here you can see the stress and strain, that external force is applied over here. Okay, and that internal force is there. Okay, so cross sectional area is there. So if you give some external force, so your study will be like that how much deformation is there. Okay, so how much deformation is there there are different positions like length. Okay, then area, then here you can here you are getting that L is there, then delta L is changing. So if delta L is changed, so diameter, that d0 will be reduced to d0 minus delta d. Okay, that portion will be there. Okay, so if the deformation is there, and due to the deformation is any kinds of force is applied over here, that is your calculations. That must be your calculations. You have to calculate it, how much deformation is there, and based on the deformations, means strain applied of your stress. Okay, so you have to calculate the strain. So unbounded resistance where strain gauge. So different types are there. So here you can see diagram of a unbounded. So cross sectional springs are there. So if you give that force over there, okay, so that movement will be there. So very less because it is your resistance wire is there. Okay, that wire, two wires are there. Okay, so it is your weld point. So welding you have to give in. So ring and spherical beams are there. Okay, so if you give the force over here, how much deformation is there, that you have to be calculate. Okay, and as per that calculation you will get that value. stationary or the fixed base. Okay, so here you are getting the stationary or the fixed base, and you are applied the force over here, and that main platform movable arm, so that arm is movable. So that point is connected with your movable portion, that fixed portion is connected with the movable portion. So now if you apply the force, so that horizontal force, okay, that may cause for changing of that length of this connector. Okay, so that length changing of this connector may cause for the stretched unbound strain gauge wire. Okay, so filaments of strain of the sensitive wire, so changing of that length may cause for generation of some electrical signal that you need to be measured. Then bounded resistance wire gauge. So previous one you can say that was unbounded, but here, so now you are giving some leads are there, electrical leads are there, and that fine wire. Okay, so fine wire are connecting like a fine wires are connecting like a spring. Okay, so direction of the strain. Okay, so now it is moving ups and downs. Okay, and support base is there as per the movement. Then what happened, the spring resistance. Okay, so that will be changed, basically that movement that in the length, the deformations, that resistance will be changed. The resistance equals to rho L by A. So if any of them has changed, okay, so length or A, so then what happened, then your resistance will be changed. Okay, so tension cause resistance increase. Okay, so tension cause means L is increased. If L is increased, so that your resistance will be increased. That is your bonded strain gauge. Okay, so gauge in intensity to lateral force and resistance measured between 2 points. Okay, 2 points are there, to lead are there. Okay, that you have to calculate. Compression cause for the resistance decrease. Okay, so that cause for resistance decrease. So here it's your gauge factors. You have to calculate the gauge factors. Okay, change, that is a ratio of the change of resistance per unit change of resistance and per unit change of your length at the presence of stress. That the ratio is called the gauge factor, that you have to calculate. So here you are using that active gauge, and it is your dummy gauge. Okay, both the gauge are there. Okay, so R1 given value, and some three things are given. So one, you have to be calculate, and you have to measure that output, means deformations will be there. If any kinds of deformation, any kind of mismatching will be there, so pointer will be connected as the output terminal. So at the terminal, that changing of that value may cause some deflections of the pointer, that you have to be calculated, and there is some standard value. Okay, that you need to know. Then type of strain gauges. What are the different types of strain gauges? Okay, so grid type strain gauges. Okay, so as per the application, different strain gauges are there. Rosselet strain gauges are there. So all the cases you can see that any kinds of forces. Okay, if the forces is acting over here, maybe a vertical range, maybe horizontal range. So what happened? So that deformations or the changing of that length, okay, or area, it is observed to the winding. Okay, that may cause for what? That may cause for generation of some electrical signal. And if the electrical signal is generated, so you are getting that value. Okay, then Rosselet gauge, what happens? So you can see there some of that different positions. You can see that grid type strain gauges, you can see that is one is vertical, one is vertical, another is horizontal, another is cross. Okay, cross between that vertical and horizontal. Okay, so two leads are there. Okay, that may cause for what? That may cause for generations. Okay, so 1 2, that is there. Okay, so any of the terminal, any of the directions, it is able to get that value. Okay, you are able to find out that gauge factors, and you are able to also find out the value of changing of the resistance with the applied force. Okay, then another few types are there. So torque type gauges are there. If the torque is provided to that gauges, so angular positions, you can see two electrical leads are there, always there. Okay, here two leads are there. Okay, as per the changing of that conductors. Okay, that length of the conductor, anything is changes, so that may cause for generation of that electrical signal, and you are able to find out that value. Okay, so you can see those value 120 ohm, C 20, 50 ohm, 100,000 ohm, all are there, and different values, changing of that values, a range it is given. Okay, so what type grids are there? Here you can see two electrical leads are there. Okay, but it is in spring type nature. Okay, so cross sectional area is look like a circular in nature. Okay, so if that value, so you are able to find out okay, any kinds of changes is there, so that electrical signal will be developed and you are able to get that value. Okay, so foil type strain gauges are there. So in foil type strain gauges you can see that different metal foils are there in the space of base is there. So after that metal foils are there, so any kinds of force is applied, so better for the higher operating temperature range. Okay, so 0.2 millimeter thick, 50 to 100 ohm, so the range is given, so 50 to 100 ohm, sorry, 1000 ohm. Okay, that foil is there, so if you apply that pressure to on it, so that foil is changed, the area or length of the foil has changed, and that may cause for deformations. Okay, the semiconductor strain gauge for the very high gauge factor, that is 130 plus 130.727 mm. So resistances are wire type. Okay, so this is your base, and semiconductor connectors are there. Okay, semiconductor connectors are there here. Okay, any kinds of pressure is there, so you can see that semiconductor pole, that means you know that holes and that electrons are there. Okay, so any for the external effects, okay, that the positions or that the movement of that holes and electrons may be changed. Okay, if it is changed, then what happened, then that may cause for changing of the current flowing over there. Okay, so that your electrodes are there and you are getting the signal from the electrodes. So gold leads are there. So why gold lead? So basically if you using that noble metals lead, so with the changes with the noble metal means it will not affected. Okay, affected by the external fields. Okay, means external environmental features. Okay, environmental points like that, the moisture, it cannot that means it is not affected by the due to the aging effects. Okay, that's why some gold leads, noble metal, you are connected over there. Okay, and you can fetch that value, the changes, but any pressure or current may be different, so you will get that value from here. Okay, from the electrodes. Then temperature measurement, so then we can go for the temperature measurement. So international practical temperature scale, okay, IPTS, okay, define the 6 primary fixed points. Okay, the reference temperature in terms of that triple points of the equilibrium of hydrogen, that is 259.34 degrees centigrade. Boiling points of the oxygen, that is 182.96. so those all are the standards. So when you are define your system temperature, okay, so that may be compared with your reference values. Okay, that reference point is given by the IPTS. Okay, so the triple points of the equilibrium of hydrogen, then boiling points of oxygen, then boiling points of water. Okay, so that is 100 degrees centigrade. Freezing point of zinc, that is given 419.58 degree. Freezing point of silver, freezing point of gold. So all are standard atmospheric pressures. Okay, the freezing points of the certain other metals are also used to secondary freezing fixed points. Okay, to provide the additional reference point during calibration procedures. Okay, so those all are values. Okay, so that is provided by IPTS and implemented for designing of different sensor and transducer. Okay, So then other important points that instrument measure temperature, that you are design some instruments. Okay, means transducer or sensor based instrument, and you are going to measure that value. Okay, so that can be divided into separate. Some classes are there. Okay, different classes are there according to the physical principle which they operate. The main principle are used. Okay, so different methods are there. Based on that method, you are you are doing the calculation. So the thermoelectric effects, okay, the resistance change, the sensitivity of the semiconductor devices, radiative heat emission, then thermography, thermal expansion, resonant frequency change, sensitivity of the fiber optic device, acoustic. So different color change, then change of the state of material. So most of them are that physical changes of that instruments. Okay, so when you are going to be select some of that sensor or transducer for measurement of temperature, so you can select any of them. Okay, means you can select the devices with certain change of temperature, the color of that elements or color of that device, that means substance has changed. Okay, so you can use the device. Then some of the devices are there. If that thermal expansions, you can observe over here the sensitivity of the semiconductor device, and with the increasing of temperature, the resistance has changed. Like carbon, okay, it has a negative temperature coefficient. So if the temperature increase, so you can observe that the current flowing through this path may be increased. The different kinds of physical parameter you can select for your designing of your transducer. Okay, then resistance or thermometers you can use. So sensing elements are there. Okay, in thermometer that elements are there, sensing element, lead support. Okay, that support also be there, connecting leads are there. Okay, then C means protective monitoring head, mounting head. Okay, so protecting sheath also be there. Okay, so any of the sensing element, you can see it's look like a breathe circuit. Any of the positions it has changed, so that galvanometer, if it is not balanced conditions, okay, that terminal, so external electrical supply terminals are given. Okay, so external electrical supply terminals are given. So if any of the conditions, means any of the time is changes, so all at the fixed, if that RS is changing, so what I mean, you can see the deflection of the galvanometer is, means galvanometer is deflecting. Okay, so that may be indications for changing of that. It is operation of thermometer. Okay, so you can see another diagrams that lead wire, then platinum coils are there, all of the platinum coils, then element supports, then quartz sheath. Okay, all are there. So you are going to be find out all those values. Okay, all those values you are going to be find out. Okay, that is your work. Okay, that you need to find out with the you can observe the changing of the temperature that may cause for changing of that temperature that may cause for changing of the resistance, and you are going to measure that amount of temperature by using this property. Okay, so here you can see some of the thermistors. Okay, so examples of thermistors. Okay, so that detecting portions are there. Thermistor means thermally sensitive resistor. Okay, TSR, so thermally, that first points, and thermistor resistor Easter. Okay, so you can add both of them, so it is written that thermistor. Okay, so disc type or 10 mm, bed type or 0.15 mm, then rod type, then 4 mm dia. Okay, 12.5 to 50 mm long. Washer type. Okay, these are the different types of thermistors. Look like that. It is resistance and temperature. So if you increase the temperature, so you can see the resistance is changing. Okay, that means hyperbolically it is reducing. So you can say like that negative temperature coefficient. So increasing of the temperature, that is reducing. Okay, so here you can see different diagrams of thermistor. Then I think you can see that animation. So how it is work. Okay, so thermally sensitive resistors are there, so that is HI, so it is there. Okay, so when that light, okay, or it is emitting over there, so higher dryer like that, it is emitting over there, the changing of the temperature, so that may cause for changing of that electricity. Okay, so here you can see the thermistor example. Okay, when that hair dryer is there in the thermistor, so that may change for that resistance. If the resistance is changed, so LED is turned on and thermistor will work. Okay, I think all of you are able to understand, and you can see that animations to know the thermistor. So you can see that voltage is applied. Okay, so 9 voltage applied, so analog voltage range. Okay. So next one you can you can see that RTD, thermistor and thermocouple. So all the cases, all are the temperature sensing elements. So you can see the thermistor having rectangular hyperbolic type of nature of their V or R with the that means temperature. That curve is look like a rectangular hyperbola. RTD initially you can see initially there is some non-linearities, after that it is linearly change. Okay, increasing of the temperature, so resistance will be increased. So in case of thermocouple, what happen, initially more or less it is fixed. Okay, voltage is fixed. If the temperature is beyond the range, then what happen, suddenly this resistance will increase. Okay, so you can see the characteristics of different RTD, thermistor and thermocouple. Okay, so
डिफॉल्टर लेके चल मिलते करते हैं तो उसका मानने डबल है डिफॉल्टर के भाई लोग कौन सा जाना ठीक है
okay, so in thermocouple, thermocouple
या तो आईजी हो सकता है आईजी डीजी आ जाता है अब महीने दिन भाई छड़ा मुआयना करे छे
So in the thermocouple, so here you can see that thermocouple, what happened. So one reference temperature is given. So all the time that reference temperature is given. Okay, reference temperature junction is there. So different metal you are using, metal 1 and metal 2. Okay, normally you are using two metals. Okay, then sensing element is connected, so temperature sensing element is connected at that point, junction of the two metal. Okay, then voltage you have appeared, so some reference temperature junction is there. Then what you can observe, giving then due to the extreme changes, so here you can see it is thermocouple construction. So how it is working, so that one is cooling. Okay, one is cooling, one another is heating. Okay, so two metals are there. Okay, metal joining, so two metals A, B. So cooling means it is that means emitting the temperature. Okay, it is reflecting the temperature, and heating means it is absorbing the temperature. So two temperature differences is there, so that may cause for what, that may cause for potential difference across that metal junctions. Okay, like that way. So two metals T1, okay, two junctions, okay, T1 and T2, two different temperature, one is cooling, okay, another one is heating. Okay, one is cooling, another one is heating. So cooling and heating is responsible for different metals. Two metals are there, A type and B type, two metals are there, that may responsible for generate some voltage across that across these two metal. Okay, so that's the basic effect of the thermocouple. So there are two types of effects. So one is called Seebeck effect, another one is called Peltier effect. Okay, so current through the two-dimensional material may cause for current flowing through this path. Okay, so you can see some I current is flowing. Two paths are there, A and B. So it is your T1 terminal and T2 junctions. Two junctions are there. Okay, so I know that all of you already gone through the Seebeck and Peltier effect in your plus 2 level syllabus. Okay, so that's why I'm not going to repeat the basic theory. So that is that you know. Okay, so here you can understand that options. Okay, so here you can see the animating diagram of a Seebeck effect and the Peltier effect. Okay, so what happened, you can see that two junctions are there. Okay, so it is your hot wire and it is your cold wire. Okay, both the cases you can see that hot wire is absorbing that heat. Okay, so you are giving the heat over there in that load is connected. Okay, so and cold wire means it is absorb heat removed, means it is hot wire it is absorb heat, cold wire it is removed means emitting the n type bismuth telluride. Okay, so electron flow like that, hollow flow, hole flow. So this is responsible for hole flow, this is responsible for electron flow. Okay, so p type bismuth is there, it is n type bismuth, p type bismuth. So say Steve Gn and Peter info. Okay, so you will get there must be the temperature difference between the hot and cold side for the power to be changed. Here you can see in it is one type of Seebeck device, it is your Seebeck device. Okay, couple consist and it is your Peltier device, and couple consists of one n type and one p type semiconductor pellet. Okay, here n type and one p type semiconductor pellet, both the configuration is more or less same. Okay, so here you can see that release heat, cold means release heat. Okay, so p type bismuth is there. Okay, so the change of carrier. Okay, so that here you can see the temperature difference. Seebeck effect, you can see the temperature difference. Peltier effect, what you can see that the change of carrier, negative electrons and positive holes transfer the heat. Okay, so changing of that electrons. Okay, so you are not specifically telling you that is your hot side and cold side, but that is responsible for the changing of the uh, electron flow. Here you can see with the hot wire and cold wire, so only that current is flowing through the load, but in this case Peltier effect you have to provide the source. Okay, that source you have to provide it. Okay, otherwise it is not possible. So if you provide the source, then you can see that one is hot side, one is cold side. Okay, and that will be the outcome, but here that cold side, hot side, that is already given. Okay, outcome is the current flowing through that load and you have to measure it. Okay, so I think you are able to see the effects of Seebeck and Peltier from that animated diagram. Okay, then we are using the thermocouples. Okay, here you can see the thermocouple, different types of thermocouples. Okay, so type T, okay, type E, J. Okay, so copper or constantan for type T thermocouple. So range is minus 200 to 400. So temperature range is temperature per degree centigrade minus 200 to 400. Sensitivity is your microvolt per degree centigrade. So it is 15 to 60. So thermocouple types and materials are used. Okay, so T, E, J, K, R, S, B, G, C. So different types of materials are there. So you can see that range is also increasing. Okay, so that voltage range, sorry, the temperature range. Okay, so it is minus 200 to 400, copper or constantan. So then chromel and that constantan, that is efficient for 0 to 850. The temperature change is 40 to 55 degrees. So here you can see more temperature changing, 15 to 60 degree per microvolt per degree centigrade. So it is your sensitivity. So all the cases you can see different types are there. So as per their type, so range of temperature and the sensitivity you can understand. Okay, then platinum. Okay, so platinum 10%, rhodium. Okay, so all the cases you will, from the table you can get some of the idea of the thermocouple. Okay, tungsten 10 also be there. Okay, so G is there, so that is tungsten 10. Okay, 26%. So how much percentage of variation of temperature? 15 to 2800. It is 30 to 1800. It is 0 to 1500. So all that is sensitivity. You can see the sensitivity is changing. Okay, so that percent 0 to 2750 and that sensitivity also changing. Okay, then thermocouple opposite output voltage, thermocouple output voltage versus temperature. Okay, so millivolt is there. Okay, so you can see that millivolt, how much voltage is increasing. Okay, and your temperature in the degree Fahrenheit. Okay, so all the degree Fahrenheit you can see it is changing. So you can see that platinum, rhodium, type S giving you which I'm giving you that type E type of thermocouples give you more temperature. Okay, but sorry, give you more voltage. Okay, that voltage is there more, that is nearer to the 90 volt, but their temperature range is less. But you can see that platinum rhodium, it is linearly increasing. Okay, so there is no non-linearity, and the temperature is up to 30 voltage is out to voltage up to 30, maximum up 30 millivolt. But type K, it is linearly increasing up to 200 to 3000. Okay, all the cases you can see it is more than 3000, type K and type S. But type T is very less, up to 600 type T. Then type J is also very less, up to, not very less, it is 1200 to 1400, means nearer to the 1300. Okay, so very less is type T. Okay, after the type J, then E, then S and K. Okay, so from this curve you can understand that millivolt generation, that means with the change of temperature, so how much voltage is developed. Okay, that you have to amplify. After that you have to amplify that voltage. So here you can see the thermocouple circuit. Okay, thermocouple circuit you have to observe. So metal A, so different metals are there, metal A, metal C. Okay, metal A, metal C, and it is a metal B. Okay, so two junctions is cold. Okay, so cold junction is there, so two cold junction is there. Okay, that is B and C junction. B and C junction. B is the junction of metal A and metal C. C is the junction of metal B and metal C. Okay, that is C junction. So these two junction you are make it cold. So ice water. Okay, so we are giving there ice water. That ice water temperature. Okay, and it is your terminal block, and the TH is there, hot junctions. Okay, so hot junction is there. Okay, so due to that hot junctions, you are giving you can observe that heat source is there. Okay, heat source is there, and that may responsible. Okay, so there is a temperature difference, so electron will be flow, so electron flow will be there. Okay, current in the circuits. Okay, so circuit current is coming from that side. Okay, so it is your voltmeter, so voltmeter can define you that how much voltage deviation is there. Okay, so ice bath for the terminal block. Okay, so you are doing the ice bath for the terminal blocks, and you are calculating those values. So thermocouple compensation circuit, so two circuits are there, so you can observe that sensing elements. Okay, so same thing, so sensing elements from here. Okay, then that is copper, and your constant, and two metals are there, it is your copper. Okay, and it is here that you are going to be calculate. So V output equal to Vs minus Vs, so type T. Okay, so type T type thermocouple you are using. Okay, so type T thermocouples. Okay, comparison circuit. So and next one is your type K. So in type K, what you are using, type T you are using copper constant. Type K means you are using nickel chromium and nickel aluminum. Okay, 2 is there, so how much voltage, 12.2 millivolt, and you are giving 300 degrees centigrade. So cold junctions compensations. Okay, so V out is coming, so V out equal to Vs minus Vr. So two leads are there, copper leads are there. Okay, so voltmeter connected, so it is type T, so copper constant. So it is the sensing element is connected J1 in copper and constant junction, and another reference junction, it is J2, that is J1, J2. J2 is coming for constant and copper, but there is some temperature difference. But here it is ice bath. Ice bath means it is your sensing point, that point is connected, means immersed in the ice. Okay, so you can see that some voltage difference will be observed over there. Okay, so all the sensing path you can see some of the voltage difference is there, and the presence of that voltage difference you just calculate that value. Okay, so if you are able to calculate that value, you can give the scaling of the system. Okay, and you are able to find out that value. Okay, so type J thermocouple using isothermal block. Okay, so what you are doing here, so ice bath will be there. Okay, so ice bath will be 0 degree centigrade. Here you can see, and another terminal T1 terminal is heating with some candle. Okay, so what are that lead? Okay, so it is your copper lead. So copper leads is there, isothermal region. Okay, so red one is your metal one, that is metal one, and your metal 2 is there, so that is your metal 2. Okay, so now one portion you are heating, another portion making it 0. So now we are going to find out. So same thing, you can see that isothermal block, so you just replacing those value. So that leads are there, that is copper, and junctions. Okay, that junction is there, J2 J4, that junction. So it is your iron. Another one is your constant iron and constant iron. T1 you are giving sensing element, so you are heating with some candle. Another portion, that V2 is developed as that point, so that is T reference. Okay, the reference means it is 0 degree, so it is ice bath. You are giving that ice bath. So reference junction temperature is T reference, and you are going to sense that temperature T1. So due to the difference of these two temperatures, so you are able to, you can measure some of the voltage appear across your terminals. Okay, that is your motivation to find out that value. Okay, that value you are going to find out. There is a voltmeter. Okay, I think all of you are able to understand that purpose of that thermocouples and how it is working. Then reference junction compensations. Okay, so again you are using block temperature, that is T reference. Okay, that is your T reference and RT. So different arrangements are there. Okay, so reference junction compensations. So thermistor is here, that is measuring that RT. So isothermal blocks and the reference block, reference junction, that is your reference junction sensing elements is there, plus minus. Okay, so it is your copper, and you are measuring that output. Okay, so two copper leads are here. Okay, so voltmeter you are going to be calculate that value J3 and J4. Okay, two junctions are there, ferric and copper and carbon, two elements you have using over here for that value. So you are getting some of the voltage is appeared. Okay, so it is a reference value, it is J1. So why the reference is important? So if you know the value of reference signal as a reference junction, so you are easily find out that temperature that you can calculate from J1. Okay, so difference, if you know that value of reference, so if so the resultant value is J1 minus 0, like that. Okay, or reference value. Okay, so multiple thermocouples are connected here, you can see in series. Okay, so thermocouples, so wires are there. Okay, multiple junctions thermocouple circuit designed to amplify the output signal. So the main problem is that, so in sensor or transducers, so there is a the generated voltage. Okay, so that generated signal strength is very less, so you have to amplify that value. Okay, so how do you amplify? So you can design some of the amplifier circuit. Okay, so in electrical circuit, we are much more focused about that electrical measurements. Okay, so electrical or electronics measurements. So that sensor, instead of sensor, you are using most of the cases the transducer. So outcome is coming in electricals. Okay, electrical energy. Okay, so we have to amplify that value sometimes. So otherwise we are not able to measure that value. So that, so here you can go for that amplification circuit. Otherwise you can go for that thermocouples wire. Okay, so more different thermocouples, 1, 2, up to n thermocouples are there. They are measuring junctions are there, so you can add them. Okay, so they are connected in series. So it is your copper. Okay, so coppers are there and reference junction is there. Okay, so copper and reference junction is there. Okay, you add both of them. So copper connecting wires are there. Okay, that is copper connecting wire. And here you can go for that potentiometer. So you can measure that data. Okay, measure that value. So means voltage measurement you can able to do it. So if you want to provide some temperature difference, okay, to that junction, so what you need to do? So ice bath, you are giving one ice bath to that first case. That means here you are adding some of the reference junction. Now you are telling you that it's an reference junction. So you can give the ice bath over here. So these two are the copper and maybe they are ferric, okay, or iron. So these all are the measuring junction. These 1, 2 and N, that's all are the measuring junction. So that is defined 1 dash, 2 dash and N dash. So these all are the measuring junction. So in reference junction, so you should give some ice bath, so making it 0. Okay, so that's why you are giving ice baths for the standardizations. Okay, now you are easily able to find out that value. You can define subtract them, so you are easily find out that value. So potentiometer is there. Okay, so you are getting that amount of value and voltage. Then thermocouples are parallel. So if that current strength is more, okay, so series means voltage strength is more required, parallel means required current strength is more. So in that case you are adding all the thermocouples. Okay, so thermocouples wires are there, so copper connecting wires there, you are connecting in parallel conditions. Okay, they all are in parallel. So A, so 3 terminals are there. Okay, 1, 2, N. So all are in parallel. So it is your reference junctions. Okay, so measuring junctions are there. Okay, so copper leads are there. So potentiometer is responsible for measuring the voltage value. So EMF is there. So we are making the mean of that entire generated EMF equal to I equal to 1 to N. That EMF is there. So you are connecting that value, adding them. So it is your T bar is there, so equal to 1 by N equal to 1 to N Ti. Okay, the temperature is there. Okay, so different types of thermocouples. From here you can see that from the diagram that different thermocouples are there, that I have already discussed. Okay, so you can see some thermocouples are connected over there. Okay, so there is some protective sheath that there. Okay, so protective head is there, otherwise it may damage. Okay, so reference, how you get the reference and heated and reference and heated. Reference means you are giving that ice bath of that points, and heated means you are giving some temperature. Compensating circuit, it is your voltmeter. Okay, so it is metal tube type. Okay, then hydromic type, then washer type. So different options are there. Okay. So advantages and disadvantages, what you can observe from this study. Okay, so first, wide temperature range, that is minus 270 degree to 2700, means 2700 degrees centigrade. That is a very wide range and robust construction. So construction is very robust, so there is some less chances to damage the device. So not damage means all the time it is try to give you the accurate value. Okay, that means the robust means rugs means that is try to give you all the time accurate value and exact value. Okay, so breach circuit not required. Breach circuit not required for temperature measurement. So otherwise what happen if it is not working properly? So again you have to go for that breach configurations for making the system balance. So when you are switching over to the breach configuration, so it is coming the complicated value. Okay, so that's why breach configuration is not mandatory for this study. The comparatively cheaper cost. Okay, good reproducibility. Reproducibility means multiple times you will get that exactly more or less same value. Okay, so that's why the repeatability. Okay, repeatability is very good. Okay, speed of response. Okay, so another big important issue. So how fast it is measuring. Okay, that speed of response is high compared to the thermometer type instrument. So measuring of temperature. Okay, so first we started with some vibration, measurement of vibration. That means in microphone. So diaphragm are moving, then we are calculating the electrical energy. After that we are switched to strain gauge. Okay, strain gauge means the force you are given. After giving the force, that is responsible for the deformations of the wire. Okay, so that may represent that may give you some changes of the resistance, and you are able to find out the voltage over there, and you can identify how much changes is there and how you are going to be calculated. That is second. Third one is temperature measurement. Okay, so temperature measurement, initially what we are using thermometer. So thermometer, there is some difficulties. Okay, sometimes difficulties is there, means some limitations are there, so that's why we can switch that one to our RTD, means thermocouple based measurement. So in thermocouple based measurement, what you can see that response speed is good, okay, compared to your temperature based, means thermometer based. Okay, so there is some heating, so definitely it will take some time. Still, some of the heating and cooling also be there in thermocouple, but comparative study, okay, in their comparative study, thermocouple gives you the better response, means fast response compared to your thermometer response. Then calibration checks, okay, calibration checks can be easily performed. So you know that beginning of this thermocouple, so I told you some specifications, or that calibrations is provided by some or international organizations. Okay, if you follow those value, and you can all the time you can monitor your thermocouple or temperature measuring instruments, okay, with those values, so you can easily get that calibrated one, okay, calibrated results. Okay, using extensions, lead and compensating cables, okay, long distance transmissions for temperature measure is possible. So that you can easily measure that boiler temperature, okay, so that that thermocouples you have placed inside of that boiler, and then some temperature will be there, is some different changes of the temperature maybe there, okay, so you can measure some electrical signal is developed, and you can get that electrical signal to a extension cord, and you can measure it at your monitoring room. Okay, but there is a problem, some losses may be there, okay, the temperature, that long distance transmissions, okay, means from boiler point to your control panel, so some of the data may be lost. Okay, so there is some possibilities, okay, for losing of the data, otherwise it is also possible. Okay, so by using extension cord you can get the data in good accuracy, so accuracy also very good. Okay, repetitively, if you see, if you check it multiple times, so all the times will give you that all the times it give you the same type of results. Okay, then compensation circuit, okay, so compensation circuit is essential. Okay, compensation circuit is essential for accurate measurement. So compensation means you are in temperature measurement, your system should be in closed loop. Okay, so closed loop means one controller must be required, so reference signal always be there, reference value of temperature, then measure value of temperature, both should be present in the system. Then one processing unit will be there. Okay, so after that one differential amplifier, so from the differential amplifier some error will be developed, and that error should be passing through the compensation block or the controller block to minimizing that error. Okay, that's why it is called that compensation block is all the time it is mandatory and necessary for measurement of temperature. That's why you can see for the measurement of temperature you are using the closed loop system, not for the open loop system. Okay, many exhibit non-linearity in the EMF versus the temperature characteristics. So sometimes you can also observe there is a options for the non-linearity. Okay, so initially sometimes you can see that material you are using now, the type J, type T, different types of thermocouples you are using. So some of the thermocouples having non-linearities, means changing of your X, the ratio of changing of your X axis and the Y axis is not fixed throughout the path. Okay, some portion it is different with the other portions, that may indications for the non-linearity to your system, introduction of the non-linearity to your system. That is another limitation. So first few points, first all the points are for that advantages, so last 4 points are for the disadvantages. Okay, so comparatively you can see that advantages is more compared to your disadvantages. Okay, that's why it is so popular. Okay, so many application needs signal amplifications, that is another disadvantages. So generation of the signal, that developed signal strength is very less, okay, in millivolt range. So definitely there is some error for measuring purpose. So millivolt range. Okay, so definitely measuring purpose there some error will be there. That's why you should add some of the gaining factor to scale down this voltage level, or to amplify that voltage level. Okay, that's why additional circuitry is required. Okay, the proper separations, okay, the proper separations, separation of extension lead from thermocouples is required to avoid the stray electrical signal pickup. Okay, so definitely sometimes what happen, stray field may cause or may opposing the sudden pickup of the thermocouples. Okay, that may be another problem. Okay, so external field having effect on your instruments. Okay, so that's why you should keep in your mind, okay, there should not be presence of any external field. Okay, so the up to thermocouples, okay, that is enough for today's discussion. So in tomorrow there is another most important discussions on LVDT. Okay, so variable inductance type transducers. Okay, so this is very important. Okay, so that thermocouples also very important. So I think today I am covered up to thermocouple. Okay, so two things I have completed. So strain gauge and thermocouples by today's lecture. So if you have any kinds of confusions, you can ask me. Any kinds of difficulties, you can ask me. Okay, so we can complete our sessions. So I think no one is asking me any questions. So I think most of them don't have any kinds of doubts. Okay, so if you have any doubts, you can ask me in my next class also. So you please go through that sensor and transducer, any of the standard books. Okay, so it is well-known topics. Okay, and you can follow any of the books for build up your knowledge, develop your idea. Okay, so I think there is no questions from audience, so I can stop today's sessions. Thank you.